Chapter 4. Types of Fire Alarm and Detection Systems. Our objectives. List and discuss the different fire alarm system classifications. List and discuss the interface capabilities between fire alarm systems and other building fire protection and life safety systems. List and discuss the different conditions, situations, and circumstances used to determine manual fire alarm and automatic detection system installation requirements. Describe the difference, acceptance, and periodic inspections, test, and maintenance activities required for fire alarm systems. The type of fire alarm system installed in a particular building depends on many factors established by the model codes. Systems are classified according to the certain operational events that take place when the system activates. The person or party responsible for the activities associated with this alarm is determined by the type of system installed. This chapter covers the integration of fire alarm systems with other fire protection, building, and life safety systems, the installation requirements for a particular type of system, the reference standard used to design and install manual fire alarm and automatic detection systems, the requirements for system acceptance inspections and testing and periodic inspection, testing, and maintenance. System classification is based on the following: which operational events take place, how the operational events take place, and whether the system serves more than one purpose. And yet again, our standard of reference is NFPA 72, the National Fire Alarm and Single Code, which established 2 broad system classifications and 5 subcategories that we'll go into later. Fire alarm systems. The number and type of alarm detectors installed usually depends on the size and layout of the building, the year of construction, and the code enforced at the time of construction. Detectors require a visible power light and a means of testing the device. Single and multiple station combinations and household fire alarm systems are typically found in residential occupancies. The single station alarm system is an alarm/detector that operates independently from other alarm systems and detectors. They are also called a smoke alarm. They consist of an integrated sensing device, a power source, and an audible alarm, typically found in older homes built before they were mandatory requirements for smoke alarms and residential occupancies. No wiring is involved, so these are easy to install and are reasonably priced. Multiple station alarm systems consist of a number of interconnected smoke alarm units. Upon activation of one alarm, all units sound an alarm. They have been required for years by all model code organizations. Each unit consists of an integrated sensing device, a power source, and an audible alarm. Combination systems consist of the following: fire warning equipment, burglar alarms, medical alarms, and other sensing equipment such as carbon monoxide detectors. They can also monitor other fire systems and transmit alarms to a monitoring company. Household fire alarm systems utilize a fire control panel to provide an interface between the following: your system devices, primary and backup power, alarm functions, and monitor capabilities to ensure the system's integrity. Protected premises fire alarm systems are typically found in commercial and industrial buildings. They provide audio and visual notifications within the property they are protecting. They alert occupants of a fire emergency. They notify occupants or staff of system trouble and supervisory conditions. They may be a single manual fire alarm box and bell system. Some interface with other fire protection, building, and life safety systems. Some, but not all, have communication capabilities that report to an on or off-site location to initiate the appropriate response. Supervising station alarm systems protect homes, buildings provided by on or off-site monitoring for alarm system singles. A central station services the fire alarm system. A true central station fire service fire alarm system establishes a high level of service to ensure timely, efficiently, and appropriate handling of fire protection system related issues at a protected property. Number of approved systems and means can provide communication between the protected property and the central station. The most common is a system that uses digital alarm communicator transmission, known as DACT, at the premises, and a digital alarm communication receiver, abbreviated as DACR. Once a fire alarm system activates, a fire, trouble, or supervisor signal is sent to the DACT panel, which then transmits the signal to the central station facility via an approved transmission medium. Two methods of transmission are required to ensure redundancy and backup protection. Once the central station receives a signal, the station personnel takes appropriate action. Remote supervising station fire alarm systems. They are set up to report alarm trouble and supervisor signals generated by protected premises systems to a local distance from the particular facility and property protected purposes. Signals are sent directly to a fire safety communication center or to an approved location where trained individuals monitor the signals at all times. Proprietary supervising fire alarm systems. They establish building and property owners as the responsible party to monitor the fire alarm system signals at their facility. They typically consist of a number of fire alarm systems on a property spread throughout an area or region in a building under control of a single user. Transmitting signals to a central monitoring location staffed 24 hours a day by trained personnel who will take an appropriate action upon receipt of the signal. They can be set up to handle building control functions as well, such as elevator control, smoke control, stairway tower pressurization, stair tower and exit door lock releases, and shutdown of manufacturing or other processes. Public emergency alarm reporting systems transmit alarms throughout circuits connected to the municipal communication system. Typically are publicly accessible alarm boxes located on the street. An auxiliary fire alarm system may connect to and use the same transmission equipment as the public emergency alarm reporting system to transmit fire alarm signals. Local energy fire alarm systems. Self-contained systems with a power source not dependent on current from municipal circuits. Shunt auxiliary fire alarm systems. They use power from the municipal fire alarm circuits to supply currents to the building fire alarm system. Only manually initiating and water flow switches can connect to this type of system. Emergency communication systems. A one-way emergency communication system receives accurate and timely information, is critical to a building, facility, campus, and complex occupants, and mass notification systems can relay the information needed to protect life. Distributed recipient mass notification systems transmit directly to individuals or groups using such things as text messages, paging alerts, emails, and phone calls, as well as interfacing with other traditional communication systems, and media. In building emergency voice alarm communication system, EVACs, it provides first responders with a notification tool to manage occupant evacuation. It can be standalone or an integrated part of a facility's fire alarm system. Primarily installed in high-rise buildings with large occupant loads and special amusement buildings. They provide a voice message notification as well as visual notification, which typically consists of strobe lights. Fire, Emergency Command Center, and high-rise fire alarm system packages. They house the fire alarm control and announcement panels. The command center must be separated from the remainder of the building by 1 hour fire-resistant rated fire barriers. In building mass notification systems, similar to EVAC systems, but can play a larger role in emergency situations. They can interface with the building EVAC system and fire alarm systems. It contains many other monitoring devices that provide input to alert individuals inside and outside of the building, such as message boards, graphics, textual, tactile, or voice notifications. They can be gas-detected monitoring devices, weather alert systems, and regional and national alert systems as well. Wide area mass notification systems. They serve outdoor areas, such as business complexes, campuses, military bases, and in some instances, small communities. They distribute information primarily through some high-powered speaker array. Two-way emergency communication systems permit first responders, and in some cases building occupants, the opportunity to communicate between specific locations, such as fire phones or firefighter telephones, which directly connect to the fire control room. They reside on each floor level. They are a more expensive component of a fire alarm system, and they often lack maintenance, creating an unreliable service. Interfacing with other systems. The fire alarm system can perform the following functions: unlock exit doors, provide re-entry into the building to find an alternate exit, and can be automatic or manual. They can also close doors, releasing the devices holding a door open and create a smoke or fire barrier. They can recall and shut down elevators. Starts when an elevator lobby, machine room, or hoistway smoke detector activates. It sends a signal to the elevator cars to travel to a predetermined location. This serves two purposes. It does to prevent the use of the elevator during a fire emergency and to place elevators in position so firefighters have access to them. It may turn on or shut down air handling equipment. Stopping the circulation of air contaminated by smoke and hot gases is critical to life safety. Widespread propagation of smoke and hot gases can be prevented by shutting down the system. Startup smoke control and management equipment. It interfaces with the fire alarm system for automatic startup of pressurized systems and other smoke removal equipment. They provide tenable environments that is critical to ensure the building occupants are able to exit safely. It can close fire dampers, which can automatically shut to prevent propagation of smoke and hot gases and flames through the HVAC system. Monitor and activate fire suppression systems. For most automatic fire sprinkler systems, alarm activation occurs throughout the system's water flow switch. Some water-based and gaseous suppression systems are activated by an alarm initiation device. Required installations. NFPA or ICC model codes establish the requirements of where manual fire alarm systems and automatic fire detection systems must be installed based on a wide range of characteristics, such as use and occupancy, the number of occupants, the levels above or below exit discharge, types of products used or manufactured, and whether other fire protection systems will be installed. Some property use and occupancies are not suited for manual fire alarm systems or automatic detection systems. Use, group, and occupancy. The use and occupancy of a building are the first factors to consider. Installing a fire alarm system can be especially important when a building is large or a large number of people work, visit, or live in the building. Typical issues that arise from these types of buildings include limited occupant familiarity with the entire building, limited occupant ability to know what is going on throughout the entire building, and limited ability to provide quick notification to occupants throughout the building. Factors and considerations may be specific to the use or occupancy. All of these meet a specific threshold before the installation requirement is valid or before an exception changes the requirement, such as occupancy load, again, capability, height, and the number of levels of below or above exit discharge. Number of occupants. The number of individuals and their location in the structure are important factors to consider. There are differences in the occupant threshold limit between NFPA, Model Code, and the ICC. For assembly occupancies, both NFPA Model Code and ICC have the same installation requirements. Occupant loads exceeding 300 occupants require installation of manual fire alarms. This requirement is regardless of where occupants are in the building. The occupancy load does not factor into requirements for automatic smoke detection in assembly or building occupancies. Building height. The requirement does not necessarily hinge on how many feet the building is above ground or grade level. It depends on the number of levels above or below an exit discharge. Neither of the model codes determine requirements for smoke detections based on building heights. The level of exit discharge. The number of occupants who are above or below the discharge level will determine if a manual fire alarm is required. The IBC indicates that businesses, factories, mercantile, and residential apartment buildings are required to have manual alarm systems installed based on the level of exit discharge. Neither of the model code requirement requires automatic smoke detector installations purely based on the level of exit discharge. Manufacturing and use products. Both model codes require manual fire alarm systems in semiconductor manufacturing facilities. IBC requires manual fire alarm systems and occupancy use for manufacturing of organic coatings. The use of certain products establish requirements for automatic detection systems are highly toxic gases, organic pesticides, and oxidizers stored or used exceeding the maximum permitted amount. Special use and occupancy conditions. In some instances, requirements for manual fire alarms and automatic fire detection exist due to specialty use occupancy conditions where the normal level of protection is inadequate. IBC requires a manual fire alarm system in deep underground buildings where the lowest level of the structure is more than 60 feet below the lowest level of discharge. IBC requires automatic fire detection in certain areas of any building classified as a high-rise building regardless of use classifications, such as office buildings, hotels, apartments, condominiums, and telephone switching centers. Both model codes require automatic fire detection in the building. Is considered a special amusement building. Installation of other fire protection systems. In some occupancies, automatic sprinkler systems permit the exclusion of manual fire alarm boxes, as long as the notification appliance sounds an alarm when a water flow alarm activates. Automatic system installation permit omissions of smoke detectors in only a few situations. NFPA 72 provides application, design, installation, inspection, testing, and maintenance requirements. It has information concerning components, hardware, system type, calculations, power requirements, performance reliability, supplemental integration, and interface guidelines. It established minimum requirements for installation. It's not an installation specification or approval guide. It does not provide methods to achieve requirements. Reference and other standards to deal with specific issues relating to the installation of fire alarm and detection systems. Fire alarm system inspection and testing overview. The operational integrity of the system hinges on the initial acceptance testing, as well as a lifetime of periodic inspection and testing. The acceptance test establishes that the system is ready to operate as designed. The periodic inspections and tests ensure continued reliability and performance. Failure to appropriately perform either could contribute to death and injury. Acceptance test. The process starts with a sound design through plan review and solid documentation. Next, proper installation and inspection oversights are required throughout the construction phase, with a final operational and functional inspection and test before the building is occupied. The final acceptance test preparation. Installers must provide a record of completion documents. The test is scheduled and notifications to building occupants are posted. The test is performed. Functional testing requires that the device be put through an actual operational test, not a simulated test. When an existing system is repaired, modified, or added to, NFPA 72 specifies testing 100% of the device directly affected by the change, and testing 10% up to 50 units of the existing initiating device not affected by the change. Periodic inspections, testing, service, and maintenance. Many false alarms are due to the lack of improper inspection, testing, service, and maintenance. Fire alarm systems must be inspected, tested, serviced, and maintained just as frequently, if not more so, as other building systems, such as the electrical, plumbing, and mechanical. NFPA 72 provides a detailed inspection and testing intervals for all fire alarm system components. It includes task-specific information to indicate the minimum acceptable level of system recertification. This includes visual inspection as well as functional testing. Inspection and testing intervals vary for the different devices and components, but range from weekly to annually. Summary. Again, NFPA 72 classifies fire alarm systems based on the operational events of the system and how single monitoring and reporting take place in the system. Some systems rely on a person to initiate an alarm and notify the fire department. Other systems automatically activate and report to an on-site location for investigation by staff. The most sophisticated systems automatically activate and report the exact location and type of the device to an on- and off-site personnel. Installation requirements for fire alarm and detection systems depend on the use and occupancy conditions. Factors and considerations including occupant load, occupant capability, and the building height or the number of levels above or below exit discharge. Additional requirements for fire alarm and/or detection system installations are determined by special use and occupancy conditions, the manufacturing of certain products, and the installation of other fire protection systems. NFPA 72, the National Fire Alarm and Signaling Code, has been and continues to be the standard for fire alarm and detection system design, installation, inspection, testing, and service. However, as comprehensive as NFPA 72 is, reference to other standards is needed to properly design and install fire alarm and detection systems. The Fire Alarm System Acceptance Test establishes the minimum system installation and operational characteristics. Periodic inspection, testing, service, and maintenance ensures system reliability. Okay, gang, this wraps up Chapter 4 for us. If you have any questions, again, you can email me at aroberts@athenstech.edu or call me at the office at 706-357-0162. Hope you guys have a great day. Talk to you later.